Why do brittle materials fracture easily despite flaws? Have you ever wondered why some materials seem to break so easily, even when they have flaws? Today, we will tackle the question of why brittle materials fracture so readily despite imperfections. Brittle materials are unique because they do not bend or stretch much before breaking. Instead, they tend to snap suddenly when stressed. This behavior is due to their limited ability to deform plastically. When a crack or flaw is present, the stress around that flaw becomes concentrated. In brittle materials, this concentration leads to quick crack growth without any significant deformation to slow it down. Even small flaws can result in sudden and catastrophic failure under relatively low stress. Brittle materials typically behave elastically until they reach their breaking point. This means they can return to their original shape when stress is removed, but once they exceed that limit, they break sharply. Unlike ductile materials, which can change shape and absorb energy, brittle materials absorb very little energy before they fail. Flaws such as microcracks or notches act as stress concentrators. The stress intensity at these points can exceed the material's fracture toughness, which is the measure of resistance to crack growth. This causes the crack to extend rapidly. The fracture often occurs along specific planes within the material, resulting in a flat and shiny surface with minimal distortion. Several factors make brittle materials particularly sensitive to flaws. First, their limited plastic deformation means they cannot redistribute stresses around flaws. Second, once a crack begins, it can spread extremely fast, sometimes reaching speeds close to the speed of sound in the material. Third, environmental conditions like lower temperatures can further reduce the material's ability to deform, increasing brittleness. Lastly, the thickness of the material can also play a role. Thick sections may restrict deformation in multiple directions, increasing the chance of brittle fracture under tension. From a product failure standpoint, brittle fractures can be dangerous because they can happen without warning. Flaws introduced during design, manufacturing, or material processing can serve as starting points for cracks. For example, sharp corners or welding defects can lead to unexpected failures. Understanding brittle fracture mechanisms is important in many practical applications. Glass and ceramics are common brittle materials known for their hardness but are also prone to sudden breaks due to flaws. Engineers must carefully manage flaw sizes, material thickness, operating temperatures, and stress concentrations to prevent brittle failure in components. In essence, brittle materials fracture easily despite flaws because they lack the mechanisms to absorb energy and blunt crack tips. This leads to rapid crack growth from even minor defects, resulting in sudden mechanical failures. Recognizing these mechanisms helps explain many real-world breakdowns and guides efforts to improve material reliability.